Let's talk about water. I mean, it covers over 70% of our planet. We drink it, we swim in it, we use it every single day. We think we know it, right? Well, today, we're going to pull back the curtain on water's most important and maybe most invisible role in keeping our entire world running. So, let's dive in.
But first, we really need to get one thing straight. Water is not normal. Seriously, from a science perspective, it's actually one of the weirdest, most bizarre substances we've ever found. And this is where it gets really cool. All of its oddities are exactly what makes life on Earth possible. The fact that ice floats, that's super rare, and it means lakes freeze from the top down, protecting everything living below. Its ability to be a solid, liquid, and gas all within our planet's normal temperatures, that's what drives our weather. It absorbs a ton of heat, which means our oceans act like a global thermostat. And because it's such a great solvent, it carries nutrients through soil, plants, and, our own bodies. Bottom line, water's weirdness is its superpower.
Okay, but here's the thing. Most of the fresh water we rely on to survive isn't in those rivers and lakes we see every day. Nope, it's hidden away in a massive planetary bank account literally right under our feet.
And this is the hero of our story today, groundwater. It's the water that soaks into the ground from rain, filling up all the little cracks and spaces in soil, sand, and rock. We're not talking about some mythical underground river here. It's this slow-moving, saturated zone of water that is just absolutely vital.
And get ready for this number, because it's wild. Over 96%. That's right, more than 96% of all the planet's liquid, usable fresh water is groundwater. The rivers and lakes we see, they're just the tip of the iceberg, literally. The real action is happening underground.
So, you might be wondering, how do we even study something we can't see? Well, scientists called hydrologists have some pretty clever tools up their sleeves. This thing right here is a neutron probe. Basically, it sends out these tiny particles that slow way down when they hit water. By counting how many slow down and bounce back, scientists can get a super precise measurement of how much water is in the soil, all without digging a single hole. It's how they make the invisible visible. And here's the catch. This isn't like a checking account that gets topped up every time it rains. A lot of this groundwater is ancient. Think of it more like a deep savings account, one that took centuries, even millennia, to build up. And that makes it a pretty finite resource on a human timescale. Which, you guessed it, brings us to the problem.
To really get a handle on what happens when we start overdrawing from this ancient account, we're going to zoom in on one of the most famous and most stressed groundwater systems in the entire world, the Ogallala Aquifer.
So the Ogallala, well, an aquifer is just a huge underground layer of rock and sand that holds water. And this one is like an immense underground sea. It stretches under 8 different states and is the reason the arid high plains became America's breadbasket.
After World War II, new pumping technology suddenly made all this water accessible for farming, and its use just exploded. I mean, look at this timeline. In 1949, less than 1 million hectares were being irrigated with this water. 20 years later, 4 million. By 1980, it was up to 6 million. We started making massive withdrawals from that ancient savings account.
And here's what happened next. This chart shows the change in the water table. That's just the upper level of the groundwater. And you can see, between 1980 and 1997, the level in Texas dropped by an average of 2.5 meters. In Kansas, 1.5 meters. Now, some places like Nebraska saw a small rise because of their geology, but the overall trend, especially in the South, was serious depletion.
And this really gets to the heart of it. We're talking about using water that might have fallen as rain back when mammoths were still roaming the earth. For us, on our time scale, it's pretty much a non-renewable resource. Once it's gone, it is gone for a very, very long time.
But it's not just about simple overuse anymore. The story has gotten way more complicated. Today, our entire planet's hidden plumbing system is being stressed out and rerouted by these huge, new, global forces.
And this slide really highlights 2 powerful and kind of contradictory new forces at play. On one hand, you've got climate change melting glaciers and permafrost. In cold places, this is actually creating new pathways for groundwater. But on the other hand, one of our biggest tools to fight climate change, planting tons of trees, can have a surprising downside. Trees are thirsty. They soak up a lot of rainwater before it ever gets a chance to seep into the ground and recharge that aquifer.
And get this number. In some drier parts of the world, planting a new forest can stop more than 90% of the potential groundwater recharge. It just goes to show you every big action we take has a reaction somewhere else in Earth's complex systems. There are no simple fixes here.
So when you combine our direct pumping with these huge indirect effects from climate and land use, what's the result? Well, we're not just using groundwater anymore. We are fundamentally rerouting the entire planet's hidden plumbing. We're changing how it moves and where it goes on a global scale.
And because all of this is happening out of sight, underground, it's driving an invisible crisis. But its consequences? Oh, they're going to affect every single one of us. So why does all this hidden water matter so much? Well, for starters, it's the backbone of global food production through irrigation. It's what keeps our rivers flowing when it's dry, which is critical for ecosystems. And get this, when we pump out too much, that water eventually makes its way to the ocean, actually contributing to sea level rise. And of course, it is the direct source of clean drinking water for billions of people. Everything is connected by this hidden system.
So, the first step to solving any problem is just being able to see it, right? And that is the core challenge here. As a recent UN report put it so well, we have to make this invisible resource visible. And we do that with better science, better monitoring, and just plain better public awareness.
Which leaves us with the ultimate question, doesn't it? In a world with growing demand and unbelievable changes, how do you manage a global resource that is absolutely fundamental to our survival, but that most of us will never, ever see? That, right there, is one of the defining challenges of our time.